Welcome to Knowledge Graphs for Enterprise AI, a practical, hands-on course where you will learn to build, query, and integrate knowledge graphs to power real-world AI applications. We will cover everything from the fundamentals of graph theory all the way through to deploying production-ready knowledge graph solutions and integrating them with large language models to build truly intelligent AI systems. We will be working primarily with Neo4j and the Cipher query language, which together represent the industry standard for enterprise knowledge graphs. If you have basic Python experience and a general awareness of AI concepts, you are exactly where you need to be. Let us get started with Module 1. Module 1 is called Introduction to Knowledge Graphs, and it runs for approximately 1 hour across 4 sections. By the end of this module, you will be able to clearly define what a knowledge graph is, explain why they matter for enterprise AI, describe the core building blocks of graph theory, and navigate the knowledge graph tool and standards landscape with confidence. Think of this module as your foundation. Everything we build later depends on getting these fundamentals right. So let us not rush through it. Take your time with the concepts, and feel free to pause and rewind whenever you need to. Here is what we will cover. Section 1.1 asks the most fundamental question: what actually is a knowledge graph? We will look at a clear definition, see how knowledge graphs differ from the databases you may already be familiar with, and explore some famous real-world examples. Section 1.2 answers the question that really matters for practitioners. Why should an enterprise use knowledge graphs for AI workloads? We will look at the limitations of traditional databases and the specific business value that knowledge graphs unlock. Section 1.3 gives you the graph theory vocabulary you need: nodes, edges, properties, and the 2 major graph models, labeled property graphs and RDF. And Section 1.4 maps out the knowledge graph ecosystem, the major tools, the open standards you should know about, and why Neo4j has become the dominant choice in enterprise. Let us begin. Section 1.1. What is a knowledge graph? Before we can do anything practical, we need a shared, precise understanding of what we are talking about. The term knowledge graph gets thrown around a lot, sometimes loosely, so let us nail down exactly what it means. A knowledge graph is a structured representation of real-world knowledge. It models the world as a network of entities and the relationships between them. Concretely, it has 3 core ingredients. First, nodes. These represent entities. An entity might be a person, a place, a drug, a company, a concept, or any real-world thing you want to track. Second, edges. These represent the relationships between entities. The edge tells you how 2 nodes are connected. And crucially, edges are not just pointers. They are typed and directional. So rather than just saying drug A and disease X are connected, you can say Drug A treats disease X. That directional label is enormously powerful. Third, properties. Both nodes and edges can carry key value pairs that add descriptive richness. A person node might have a name and an age. A works_at relationship might have a since date and a job title. Look at the diagram on the right. You can see drug A at the center, connected to disease X, a gene, a protein, and a clinical trial, each with a meaningful, named relationship. This is a knowledge graph in miniature. The structure itself is the knowledge. Now let us contrast knowledge graphs with the 2 types of databases you are probably most familiar with: relational databases and document databases. Relational databases. Think PostgreSQL, MySQL, SQL Server, are built around tables, rows, and fixed schemas. They are phenomenally good at what they were designed for: structured data with clear, stable relationships. But when you start asking multi-hop relationship questions, who are the colleagues of this person who also work in this department, you end up with deeply nested join operations that become painfully slow and complex. Document databases, think MongoDB, solve the schema rigidity problem by using nested JSON documents. They are great for hierarchical, self-contained records, but relationships between documents are still secondary citizens. You are manually embedding foreign keys or doing application-level lookups. Knowledge graphs take a completely different approach. Relationships are first-class citizens. Multi-hop traversal, following a chain of relationships through the graph, is the native operation, and it is fast by design. The schema is optional and can evolve as your understanding of the domain grows. And crucially, the meaning is in the structure, not just the data. For AI workloads in particular, where you need to reason across entities, infer new facts, and explain your conclusions, knowledge graphs are the natural fit. Let us ground this in some examples you probably interact with every day without realizing it. Google's knowledge graph powers the information panels you see in search results. When you search for a person or a place, and Google shows you a card with key facts, related entities, and people also search for suggestions. That graph contains over 500 billion facts. LinkedIn's economic graph models over 1 billion members, the companies they work at, the skills they have, and the jobs being advertised, and uses that graph to power intelligent career recommendations, job matching, and economic insights. Amazon's product graph connects hundreds of millions of products with their attributes, customer reviews, purchase patterns, and supplier relationships, enabling the recommendation engine and smart search you see on the site every day. The key insight here is that the world's most intelligent, high-value systems are not built on flat tables. They are built on graph foundations. And that is precisely why we are learning this.